All right, welcome back. Now we're going to talk about the reciprocal functions and how to graph those. So now, what do we mean? Well, of course, the reciprocal functions are going to be cosecant and secant. So realize that when we have the cosecant function and the secant function, they're the reciprocal of sine and cosine, respectively. So cosecant x is 1 over sine x, and then secant x is 1 over cosine x. Okay? Now, let's talk about it. So, for example, at a given value of x, the y-coordinate of secant x is the reciprocal of the y-coordinate of cosine x. Okay, so think about that. So the y value of cosecant x is the reciprocal of the y value of cosine x. Excuse me, sorry. Of course, when cosine is 0, the reciprocal doesn't exist, right? Just like here, when sine is 0, the reciprocal doesn't exist. Okay, which also lets us know that there are going to be vertical asymptotes. Okay, so similar to what we saw with the tangent and cotangent function. Okay. So if you look at tangent, right? So let's look at tangent x. Okay, tangent x and secant x are going to have the asymptotes at the same locations. Right? Wherever cosine is 0. So that means the vertical asymptotes for secant are going to be at when x is equal to pi over 2 plus n times pi, where n is an integer. And then of course here, as we saw with cotangent, right? Cosecant and cotangent are going to have asymptotes at the same locations, right? Which is going to be what? When x is equal to n times pi. Obviously, where n is an integer. Now, as far as graphing calculators, one of the things to note that some graphing utilities have a difficulty graphing trigonometric functions that have vertical asymptotes. So in connected mode, your graphing calculator or utility may connect parts of the graph of tangent, cotangent, secant, cosecant functions that are not supposed to be connected. Okay? In dot mode, the graphs are represented as collections of dots, so the graphs do not resemble solid curves. Okay, just to give you a warning when dealing with different graphing calculators. Okay, so now, the period. So what's the period of these? Well, the period is going to be 2 pi. Okay? The period of both of these is going to be 2 pi. Okay, which is different than tangent and cotangent. Okay, the domain of the cosecant function. Okay, so let's talk about domain, right? So let's talk about cosecant x. Okay, so what do we have here? The period is going to be 2 pi. Okay, the domain is going to be all the values of x such that x is not equal to what? Well, all the asymptotes. So it's going to be where x is not equal to n times pi. Now the range for these is going to be from negative infinity to negative 1. Right? Union from 1 to positive infinity. And as we saw, the vertical asymptotes are going to be at x equals n times pi, where n is an integer. Y-intercepts well, that's whenever x is equal, where the functions x is equal to 0. But no intercepts. There are no x-intercepts for the cosecant function. The symmetry is about the origin. And it's an odd function, right? Now, what about secant? Okay, the period is also 2 pi. The domain, right, is going to be the set of all x such that x is not equal to pi over 2 plus n pi, right? Again, where all the asymptotes are located. And likewise, the range is the same as cosecant. So that's going to go from negative infinity to negative 1 inclusive, union positive 1 to positive infinity. That's the range. vertical asymptotes, obviously they're right here, so the vertical asymptotes are equal to, hold on a second, x equals pi over 2 plus n times pi, where n is an integer. Symmetry. Y-intercept. There is a y-intercept for cosecant. It is always at 0, 1. Cosecant x, or excuse me, I'm sorry, secant x. Secant x has a y-intercept at 0, 1. Symmetry is symmetric about the y-axis, which means it's even. Okay? So symmetry is y-axis, which means it's an even function. All right. So in order to sketch the graph of these reciprocal functions, the first thing you need is you need to sketch the graph of its reciprocal. Okay? So, for example, if you have to sketch the graph of a cosecant function, you need to first graph the sine function. And then what you do is you find the reciprocals of the y-coordinates to obtain the points of the graph that are on the graph of the cosecant function. Okay, so we'll do an example and I'll show you the procedure with some examples and it'll make more sense.